so. So thank you everybody for coming. I'm Gabriele Sorrento, CEO of Mindless VR, and today I'm gonna talk about virtual reality and CAD modeling and Laislav. So he will talk about 3D printing, and we're gonna talk about how these technology talk together and what's their role in the design. I call this event CAD Loves VR because in Mindless we believe this works very well together. And as an architect, you may have felt some kind of frustrated in some particular situation when you had to communicate your project, but you had the feeling that the other person wasn't really getting it. And that's what happened to me in my past. I have been an architect, I've been an architectural student, and I found myself in this situation so many times. So today I'm gonna start exactly from that, the design process. From the idea to the building. How an idea becomes something tangible and something that, even more than tangible, where people lives in, is extremely important. So first we have an idea, typically coming from the client's idea. The client comes to you and asks for a library, school, or whatever, the dwellings. And then the team start elaborating a project. Or, even before the project, a conceptual project, a conceptual design. This is the first phase of each project.
If you want the recording to pick up, just use the mic where it's not going to.
Oh, so I need the microphone for the recording.
Exactly. Sorry.
Can you keep the microphone off?
Yes.
That's a great idea. Okay, perfect. So after a few iterations, you get to the first milestone, the conceptual design. And then you call the client back in your studio and ask him, hey, you show them? Do you like it? 99.9999 of the times they'll say no. I need this change, I need more window, more glazing, I need more space in the office, I need more rooms, or I need less of something. There's always something changing. So this is another iteration. Okay, so then the project goes back in the design studio. You have other 3 or 4 iterations where architects join together, do design reviews, and consider many alternatives. And eventually, you get to a final design. And the final design is shown to the client that probably has something to change, and then finally approve it. Once you got this straight, you go and create the construction documentation. And in this part of the process, once you get here, it's very, very costly to go back and do changes. Actually, the more step you do, the more costly is putting any change to the project. And once you got that, you go to the administrations, you file all the construction documents, and you receive the feedback from the administration. Sometimes something is missing, so there is another iteration here. Eventually, you can deploy everything to the constructor that makes the building. I hope I didn't oversimplify this process, because it's like very long, but I expect this to be even longer in reality. This is just like a model of that. So every time you reach the stage where you join together in the studio and you elaborate a new project, you have interaction, you have teamworks. And this ring of the chains are the more problematic, because that's where you have misunderstanding or where people can make mistakes that then reflects in later stages. And even if everybody is a professional, of course, so designer with designer. Not to mention that you have to involve the client in this process. So communicating with the client could be another source for misunderstanding and errors. And yeah, so the first phase is usually done with 3D models. And once you get to the construction documents, you abandon 3D and work just with 2D assets. Again, we detected two phases that can jeopardize the whole process, is the communication between designers and the communication between designer and the client. Let me show you an example.
I was with a company called Fisher Dax Associates, and they had a problem. Fisher Dax Associates is a theater consultancy, and so they work with architects to design theaters, and that's the specialty. But the experience of being in a theater seat is actually pretty hard to represent through plan sections or even renderings. And so, you know, I'd be involved in these design meetings before VR where we'd be showing someone a rendering of, you know, row Q, seat 13, and someone would be saying like, yeah, you know, the stage looks really far away. And you'd be like, well, no, it's 45 feet away, like that's a normal distance. Or they'd be like, yeah, you know, the person's head looks really close to me, like right in front. And it's like, it's a 3-foot row depth. That's like a standard row depth in theaters. So you'd have these kind of questions where you'd have people you're working with who either don't trust your expertise or just, you know, are having trouble with the medium in which you're representing the design. So immediately there was this thought, as soon as the Oculus Rift DK1 came out, like, oh, this could solve a problem. And by golly, it did. I mean.
So this is an architect from New York that, as I said, he used virtual reality to solve a design problem. And the communication between designers was so interrupted that they get to the point not to trust each other, which should never happen in a field like architecture that is not just an art, but is also science. So it's supposed to be objective and direct, streamlined. But it's not like that. However, virtual reality can have a role here. And the reason why this kind of problem happens is that because we are, during the design phase, especially if we deal with bidimensional assets like sections or renders, we are dealing with a simulation of reality, with a flattened version of reality. So a lot of information get lost. And that's the reason why there may be some misunderstanding. Virtual reality, from this extent, gives superpowers. There are a lot of aspects of virtual reality that I would really talk about, but today I will focus just on these 3 ones. So first, using virtual reality in the design process is very important because it frees you from reality constraints. It could be anything. It could be physics laws, gravity, the restriction of costs, the restriction of materials, anything that is like chaining your creativity and your productivity. Second, virtual reality allows you to design after experience, not before. And I'm gonna talk about this later. And third, very important thing is holopresence. Because virtual reality is a virtual world, many people can meet each other in this virtual world without being physically together in the same room. And this removes all the geographical obstacle in a collaboration environment. So this is how virtual reality works today, or like the current VR data flow. You have a CAD data. I put the logo of rhinoceros here because Of course, the study case I will present later is about rhinoceros, but this applies to any CAD. From the CAD data, you have some conversion phase, and I call it lossy because there's some information that you lose. This data is usually a conversion of the Rhino data into OBJ, Collada, or FBX photos. So basically meshes. Meshes is a format that is composed of, so the geometry is composed of triangles. So whatever you have is converted into triangles and then sent to the virtual reality app, usually based on Unity, Unreal, or other form of 3D engine. And this app sends the data to the VR. Let me show you an example of this. This is Revit model that has been sent to a virtual reality headset, so you're able to explore it inside. This case study is really common in architecture and VR, where VR is used for marketing, basically. This is another example. Oh, it's not. There we go. Let me launch the video. Okay. In this other example, a 3D CAD model has been exported to this render engine, and with Google Tilt Brush, the architect can add some sketches on top of that to experiment the internal layout of this building. So what's the problem with this? Of course, you can streamline from CAD to virtual reality, but you cannot streamline back, which means that once you got your project into virtual reality, you cannot edit it. Maybe some very, very sophisticated software would allow you to change material or change color to some part of your project, but you cannot really edit it. You cannot really add geometries to it. Or maybe you want to move a pillar, change a wall, or create a new room from your project based on the VR experience you just had. All you need to do is going back to the CAD, do the change, then export back. This workflow is interrupted. So there is no connection. And this is exactly the problem that Mindas solves. We created a software environment that includes all the parts together and is a bridge between CAD and virtual reality that allows you to work directly on your CAD data, being immersed in VR. On top of that, there is also a service for collaboration. So you can do it by yourself, or you can do it with your colleagues. This is what I'm talking about. This is a Rhino project of a cafe. Here in VR, the architect just removed this chair and is moving this. And this change is, in real time, is affecting the CAD data. This is just a screenshot, like a video recording from Rhino. And of course, is the other ways works as well. So in Rhino, if you move something, this is shown directly in virtual reality. By doing this video, so this video has been done by two designers. One of them was on the laptop working on Rhino, and the other one was using the HTC Vive headset. Later we can do this experiment together, of course, so you can understand what it means to be designing in VR. And you really fully understand the potential of that once you try it. So I warmly encourage you to try it, even if it may sound a little scary at the beginning. So is this process really worth it? That's the question that architects ask me usually. Why should I change the way I ever work? Well, I like to make this comparison. VR is for 3D modeling what 3D modeling and CAD was to hand drawing. So before CAD, architects had to do everything on paper and everything with ink or pencil. And they couldn't really, like, facing some changing in that situation, in that context, was super hard. And this is the same. Virtual reality is here for solving the problem of having hundreds and hundreds of iteration much faster. For example, today, if you want to communicate your project, what do? You create 3D mockups using physical material like plastic, wood, glue, whatever material your fantasy suggests you, or using 3D printing. But both are really can be to some extent very expensive and time-consuming. We calculated that a physical prototype can cost from $5,000 up to $100,000. There is not a real limit for that. It depends from the complexity of the 3D model. And it requires a lot of time, at least 2 weeks for like a decent 3D model. So using 3D physical models is not the right way to iterate and finding the solution to improve your design. As opposed to virtual model. Using virtual model doesn't take off anything from the past experience, because you can experience in full 3D thanks to virtual reality. But adds all the advantages that a virtual world adds. So you can have endless iteration in that. And because you are able to manipulate 3D CAD data in real time, you can do design review session in virtual reality. So if you are working in team with your chief architect, and let's imagine this situation. There are 3 junior architects that take care of the CAD data or the BIM data, and the chief architects that lead the team and lead design decisions. So usually the chief architect is not the one that manipulates the CAD data. They just give the direction, the vision. And they can participate at the design review session with the CAD data, so it can like point to actual geometry and even 3D sketch on it to convey the direction, the vision much faster. And when the junior architects are going to build the actual 3D model, they will do just once, because they will have understood exactly what the chief architect means. Because the chief architect knows what the clients want to go and knows the right direction. So enabling like a perfect communication between this subject in the team is key from my point of view. And then, of course, please later give me feedback about this, because we are doing a lot of research on the design process, and we really want to fully understand how even different architectural studio works. Because an interesting thing we found is that each architectural studio has a different workflow. So building a tool for everybody is a really challenging experience, trust me. So going back to here, you don't need 2 weeks before testing and validating your design assumption. It's on the fly. As soon as you are, your junior architects or yourself have a 3D model in the CAD, which is typically very fast to do, you can experience it. And that's the biggest revolution we got here. Let me show you how actually Mindas works. Two controllers, you can navigate as if it was a physical model, but you can also stretch it and reduce it in size. Select object just by touching them, then manipulate the shape of the data with your hands. Sorry about that. And this is another example about collaboration. So loading we loaded here a 3D model of a car. I was in our San Francisco office, and our CTO, that here is represented as an avatar, was from our Italian office, and we were collaborating on this project. Let me show. Oh, okay. So he asked me to open the hood of the car. So I just selected it, enabled the rotation function, and yeah, open the hood. So we talk a lot about collaboration, but we believe virtual reality can have a huge impact on design itself, on CAD design itself, because today CAD has a few limitations. Of course, Word is 3D, and so should be 3D design tool. Because when you flatten reality on a monitor, you lose something. And the proof of this is how CAD interfaces are designed. So whatever CAD software you're using, chances are that your monitor is subdivided in 4 parts. Because on one part, you would have perspective view, and on the other, you would have XY plane, YZ, and XZ plane. The reason about this is that you need to manipulate and see the object from many point of views to grasp the full, all the aspect of the object that is, of course, 3D. In VR, this problem is solved because you can access all the direction of the object, and it's up to you. So you don't really need to subdivide your work area, but you can use the whole space around you as a work area. So, and this is just one aspect. Another aspect is navigation. We recorded some designer while they were using their CAD software in their daily workflow. And there is one data that surprises us a lot. 70% of time in design is consumed in navigation process. So zooming, panning, orbiting around something. And the reason about this is that you need to explore your model from all the parts. Again, the same reason that I said before. In VR, you can do this with your hand, so you're much, much faster. And then, of course, CAD is isolated. I already told you this. We are working on collaboration, so this will solve this problem. Not to mention parallax, because on a 2D monitor, if you have a line object, the first will hide the other ones. And if you want to select an object, the CAD will ask you, which one do you really want to choose? But if you have access to the space selection, then you don't need to specify. You just go and pick that one. This will remove a few clicks in your workflow. A few clicks may sound like not a big change, not a big deal. But imagine how many times this happens in your workflow, and sum up all of this little inefficiency. You will have a big difference. For instance, let's consider the simplest geometry, 3D geometry ever, a box. To make a box in CAD software, you need 3 clicks. The first for the first point, the second for the base area, and the third one for the height. As opposed in VR, you can just give 2 points, and the box will be geometrically defined. Or another example, for making a 3D polyline. You would start doing this on one part of your monitor and then jump up to the other plane, complete your design, and then go back. And yes, this is a waste of time. In VR, you can just draw the polyline as it's supposed to be. And oh, no, I'm going to show you this later. Diego's going to talk about the vase design. But this is another experiment we did in the architectural field. We created a 3D mock-up of this building in San Francisco with Rhino. And then we did it again, going through the very same process in virtual reality. And we timed it. We spent 14, sorry, with the traditional interface, and exactly half in VR, because all these inefficiencies were removed. And remember what I said before, VR gives you superpower, and one of those was experience in design. As an architect, every day you're making a lot of assumptions. So this room will fit these people, so it should be this big. Or this wall should have these square meters or square feet of glazing in order to have enough lighting for this office, and blah, 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 blah. But those are really actually assumptions. And no matter how good you are, you may find that actual building works differently, and maybe your client wanted something slightly different. This picture speaks by itself. The designer just assumed this will be an ideal path, but the users are contradicting the design assumptions. So what if you could experience the building before it's even built? That's what we did. That's what one of our users did. He had this requirement to build this work area. It's like an office, and he was prototyping the desk. So the client said, I want our employees to have enough privacy, but also to be able to collaborate and pass documents on the other side of the desk. So could you please design me the perfect desk for this? And that's what they did. They took a standard model from the furniture provider and realized that the division wall was too high. So they fine-tuned the size of this wall in order to grant a little, like, enough privacy level, but also allowing the employees to pass this document, like the folders from one side to the other. And then, yeah, of course, high five, because we could. Because thanks to cloud collaboration, we could do that, so why not? And that's pretty much it. I want to pass the word to Jason, that will talk you about what 3D printed can add to this workflow. I presented Mindesk. We are partnered with HTC Vive, McNeil, SolidWorks, Autodesk, and Microsoft. And yeah, if you have any question, please ask me. That's a great question. So let me tell you two things. The first is that we build the software in a way that is AR, VR agnostic. So potentially you can use both. We haven't announced anything yet on the AR side, but we are definitely working on it, and soon you will be hearing something. We are collaborating with a company in the AR space to bring AR experience and 3D CAD modeling together, either actively and passively. Actively means being able to 3D design in AR. Passively means hosting people in a shared call where they can watch you working and talk with you, interact with you as the workflow goes on. You mean in the building side?
Yeah, so being able to work directly with the contractor.
That may definitely be a later stage of this software. So far, we are focusing on the design process, but you're right. There's a huge potential of AR in the building side. I'm talking about later stage for a reason, because enabling that workflow that you just described is not much about the software, but rather more about the hardware. Current AR devices need to be attached to a computer, so you would need your laptop with you. And current AR solution don't provide like a perfect tracking outdoor. So once they will figure out how to fix this, the workflow that you described will be enabled, and will be there. Dakri. Dakri. I haven't tried it. But I'll tell you another thing. I suspect that all these solutions are based on some prearranged work. It's not being connected and directly streamlined to your BIM or CAD software. or CAD data. So that definitely that is definitely the first step, but this is not what we envision for you. Like our goal is to remove any steps between the idea and the execution of the design. Would it be either in your office or on the site? So, well, but definitely, yeah, that is an interesting area of research.
We have a situation where we're taking an HDS scanner, scanning an entire environment. There are, say, 100 concrete columns, 25 feet high, very wide, and this very complex bolt system is just sticking out now. So to count them and measure them exactly would take forever. We've scanned it now, and now we're going through CAD, and because of this navigation process you spoke of, I have this beautiful bolt scan, thousands of bolts, and I'm trying to identify and measure down to the deck so that they can plate these after the fact. My question is, what limitations, because I want to work on this in VR, not in my CAD program, what are the limitations of the data type? If I'm looking at it in, is there what kind of solids, I guess I'm asking for. I have point data, so you can imagine 20 million points. And I just want to see these points as I look around at the points themselves because of the density make up this chair or your podium. So the items themselves are not as important. It's the frequency of these items, which are points. What's your mechanics of the entities that I can bring in to see in your VR? It's just points.
So, if you work with 3D scan data, the good news is that CAD software support the data type,
Yes.
which means you can open your 3D scan in CAD. And as long as it works in CAD, it will work in Mindesk as well.
Okay.
So you can explore that and design on top of that in VR. And of course, taking measures. That's definitely possible.
It looks like you're touching, dragging, it's giving you meters, inches,
Yes.
whatever you want.
Yes,
So that would be paradigm
exactly.
measurement.
Yeah.
Okay.
You can measure stuff as you were measuring this table or whatever. Yeah, exactly. Yep. Yeah.
How far is this technology from real-time renderings?
Light simulation. Say it again. The last part. Yeah. So I would assume that this is not too far, because we have been witnessing a huge improvement in the render engines and graphic card field. NVIDIA pulls out every year wonderful piece of hardware. So that's definitely not too far. We are working on our own render engine as well, so you will see something coming out in the next weeks. And as for like collaboration between different CAD software, this is what you mean? Yeah. We are working on that as well, because Mindesk is a software agnostic tool. So it's currently available on Rhino. We are about to release a version for SolidWorks, and then other CAD software will come later. And one cool feature we are experimenting is cross-CAD collaboration. So having 3D model coming from multiple CAD in the same space. So the typical study case we have here is automotive designers. They do the outside shell of the car in Rhino, and the internal parts and like technical parts in SolidWorks. So with Mindesk, they can compare the both model and check if there are collisions or like misplacements in some points. And they will help a lot their design process because they won't have to deal with export processes. Yeah. Anything else? Okay, so Diego, please come here and tell us your story. That is laser. Yeah.
Awesome. Hello. Hi, everyone. So my name is Diego Taccioli. I'm one of the founders of Slice Lab. My co-founder is Arthur Zulai. We're just taking photos back there. We're a design studio that specializes in digital design and fabrication consulting. We started the company 4 years ago, or 6 years ago now, sorry. And we've been working remotely ever since. So a lot of our stuff is really digital. So this kind of like plays into the whole VR thing, which we're about to get into. We've been experimenting with VR, especially MindDesk, over the last few months, and we want to show a couple of case studies pretty briefly to elaborate on what Gabriella was saying. So we've been working with basically 3 major different applications, which range in scale, general workflow, and application of importance, I guess. One is product design. The second being small-scale architecture, and lastly, master planning. On the side, I teach at Academy of Arts University, digital modeling and 3D printing. I teach an intro class and an advanced class, and there's a big difference between the two. And I'm basically trying to push 3D printing a little bit more at school, and just general workflow of how the students start to learn things, because it's a lot different than when I was in school. In particular, I kind of want to bring back the tactile and workflow with using your hands and sculpting, as well as drawing, and kind of combining this in a modern way with what we have now for tools and technology, that being VR. So a lot of the students that come into the intro course have never used any modeling whatsoever. So I kind of see that as an opportunity because they don't have their muscle memory set in stone like most of us do in modeling. They kind of, whatever I teach them, they're ready to learn. So when I first picked up VR, I was pretty decent at modeling. So it was pretty clunky, pretty annoying. But you know, if you're patient with it, you really get to use it pretty fast. But if you introduce someone to VR originally for modeling, you'd be surprised how fast they work with it. On the other hand, the advanced students, the ones that are really kind of top of their class, they really understand the 3D space, how Rhino works, kind of how to create geometry and what's important in terms of spatial understanding and adjacencies. So, and especially students, they get something and they start modeling and they don't get it right away, they just keep doing it. They have all day. They don't have a full-time job or anything. So they just keep going. And so it's pretty interesting to see how they're starting to use it. Especially intro students that are a little bit older and don't like computers necessarily, and they're coming in for a master's, they're really loving it because, for example, a vase, as I'm going to show you in a second, a sculptor or carpenter really loves using their hands. So this is kind of exactly what you're doing, is using your hands and then kind of scrolling around to see kind of how it works. So in a second, I'll show you a video of kind of a sped up version of walking into a VR room, drawing something out, modeling it, exporting it, and 3D printing it all within 3 hours. So I will. So this is the VR room and Academy of Arts. Basically just walk in, draw a very straightforward vase, nothing crazy, but just enough to be able to experience it as I'm modeling it versus printing it out or making it later and then figuring out if I like it or not. So basically understanding and drawing the profile, rotating the shape, looking around it and scaling it down, up and down, and then basically extruding it out to give it a little more volume, or basically give it volume so that it is 3D printable. Bring it directly into the software and print it that same day within basically 20 minutes of me getting into the software. And then this is about 3.5 hours later, taking it out and kind of experiencing it. It was a pretty fast workflow, And working with 3D printing all the time and digital modeling, you'd be surprised, even I've been working with it for probably 10 years now, you'd be surprised how different it is when you print something than you think it is. And with the VR, when I was using it with MindDesk, it was pretty straightforward because you could understand if that's 2 inches and you rolled around it, you're basically holding it. So for those who don't, I'm not familiar with 3D printing as much, I'll just give you a quick run through. This is the Formlabs printer. Basically has like a digital projection that goes below that hits a resin that's a UV polymer reactant. So everywhere the projector hits, it's a black and white image, it basically solidifies. And then it kind of comes up and it prints like a piece of, let's say the vase in this case, kind of like Terminator. It's just growing out of liquid in slow motion. This is kind of like a zoom in of what it looks like when it is in the middle of a print process. And what's kind of nice about this is if you start printing it, I can print and then just keep modeling. And then when it comes out, it's like a little intern's working for you making a model, and then you just keep printing them. If you have a few of these like I do at the Academy, I can print 20 pieces in one night, of which I could have all VR'd modeled, which is pretty nice. This is the final print. It's pretty basic, very straightforward vase. Not that impressive in terms of form and size, but to be honest, if you think about the process, you can see quickly that if I did this just as an experiment to make this presentation, you'd be surprised how fast you can do some pretty cool stuff. So the second half of the semester that I'm teaching, which is the advanced course, we're going to have a design competition to see who can create the coolest looking VR stuff. But from what we understand, this is the first print ever made from VR to print, or at least from MindDesk. Yeah, 100%. Yeah, this is the first piece, so that was kind of cool.
Is there the ability while you're designing this to do some type of dimensioning to show, width perhaps?
Yeah.
Also, of course, you could add those numbers that we saw you using.
Yeah, exactly.
So you kind of lock them up.
Totally, and you'll see with the demo in a second with Gabrielle is as you hold the two interior buttons, when you scale up and down, it gives you the exact scale sitting there.
Also, in terms of procedure, there's a procedure feel even in the earliest phases. We enable the possibility to use tools that CAD gives you, like AllSnap and alignment tool in VR. Just completely new compared to what we experience today, because you can like snap objects together magnetically if they were like magnets. Yeah, so you totally have dimensions and snapping tools to do.
So moving on to a different scale now, we're just going to get larger and larger. This is a more architectural scale. This is a tree house that we were commissioned to work on this year and is built in Santa Cruz. It's for a Glade commercial, basically like the Glade plug-in for a car. And we worked with O2 Treehouse on this project. They're like a specialist of creating all these crazy structures that hang in trees. And this was actually one of the hardest things that we've done. It's a very ambitious project that we took on, very fast schedule, and understanding the space for something like this was really difficult because obviously we've never experienced it, actually built it, or even worked on anything like this. This thing hangs from 8 winch cables from 26 trees that is subdivided and supported into the back. It's basically a zone shape with 56 panels and 1 opening. And in particular, we needed to understand what was it like to be in here, because when you're modeling this thing, you can change the perspective angle to 30 to 15% or whatever the angle is. You can kind of assume, but you don't really know. And if this is where you're going to be standing, it's pretty complex to assume that it's going to be right. So putting this thing in VR was pretty interesting because we physically got to take the controllers and climb up the ladder with the controllers and figuring out, like, it is pretty scary going up there. And in real life, it's actually pretty scary too, because the ladder's a lot longer than we thought, but also just like the narrowness and having the understanding of how to actually get into the space here was something that VR really helped us with. And the second part was understanding like how much this constricted your height when you're next to the edge, and where do you want to actually place the notch of where the floor is supported, because we had a few options, and those options could have been adjusted depending on with our metal worker and engineer where we wanted to put it. And also just like the understanding of this glass floor in this particular quadrant was a lot scarier when we experienced it in real life, but it was totally exactly the same when we were in the VR. Same with the way that kind of went over your body. This thing was all built for a commercial. It's basically like, core and shell of a building. This is the core and shell. We will be finishing out the interior of this, and this will be on Airbnb, hopefully within the next, it will not be on Airbnb within the next few months, but it will be in its process of going to the point of taking these little cots that we put in there for the commercial to actually making an habitable space and, grabbing on an extra piece of the bathroom, shower, water, etc. But yeah, these are operable windows and everything, and it's one of the type of projects we take on is people say, we need to get this built in a month. We have no idea how to do it. We have confidence that we can model it, but they don't take reality to it. So that's something we specialize in. So a lot of times we get consulting issues with that question. We modeled nothing with VR on this. We only experienced with VR. With this, it was a lot more difficult to be modeling it, and it was just too real to be putting a human person in it to be doing that. But we were in it to stand around it and physically walk around and try opening the door that goes underneath, opening the windows that pull down, especially climbing it up to see that, like I said, that entry point, because basically we just took out one pedal. What we wanted to take out was one pedal versus taking out 4 pedals, which would create a huge opening, not as aesthetically like we want it, and also just the rain would way more enter in that way. Yeah, we basically use that to interact with the already modeled structure, and mostly to experience, where the floor level we wanted to be, and if the windows were what we thought in terms of where they're lining up and the height and stuff. Lastly, I'm going to close with a larger project, which is a master planning project. I also work for a WRNS studio, and this is the Microsoft campus in Mountain View that's currently under construction. This is an enormous building, or whole campus. It's 1.3 million square feet, right next to the highway. It was one of the first projects I was on when I'm at WRNS, and understanding it is really like, it's quite a scale that it's really just fully new to me, and I've been working on projects this size all the time. But because it's a 2-story mall built type construction, it's very flat but long. So understanding the spaces is really important, because if we're on top, we're emphasizing the green to go all over these roofs and connect that and so forth. You got to really understand, like, how far is that? Even though you know the distance, like, what does it look like? Am I really going to walk from there to there to get food? Am I going to go down there to do that or whatever? So this is one of the buildings. We did not use MindDesk on this in particular, but we used VR. In VR, we basically bounced around and understood the spaces and stuff. We could have totally used MindDesk on this because it's a very rectilinear program, rectilinear building, and pretty straightforward program overall. And we did, when we were modeling, moving this thing all around a lot faster than we could have potentially done that and that. And just to give you a better scale of it, this is a zoom in, and that's a person right there. So it's like these little spaces that look little are enormous. And understanding, what scale of furniture, vegetation, et cetera, and so forth is quite challenging for something that looks pretty nice on paper and very rectilinear and nice to draw. But when you zoom in, especially for me, I don't have like 50 years experience. This is definitely still very challenging for me to understand, and the VR was very helpful. Yeah, that's basically all. There's 3 case studies that I wanted to show you guys. Once again, we're Slice Lab. My name is Diego Taccioli. This is Arthur Zulai. Thank you, Gabriel.
And let me adjust the thing. I want to announce that the next 10th and 11th March, MindDesk will be hosted in World's Fair Nano in San Francisco, Pier 48. So I really suggest you to check it out, because there will be not only us, but a lot of startups and researchers and innovators. So It's gonna be fun. Don't miss it out. Uh, Not planned yet, but maybe. Yeah. We're building the schedule for this fall. Well, yeah. If you have any more question, ask, or you can have some snacks, and we're gonna prepare the demo for you. Oh yeah.
If you were to begin right now and you were going to model, going to make a brand new horse studio, whatever, right out in the middle of your field, would you have a CAD? You keep mentioning CAD modeling software that you use, as you do your process. Is there a CAD package that you would always prefer, like customers talking to you and they use any number of CAD, Rhino, Autodesk Inventor, straight AutoCAD 3D, whatever it might be? Do you say, hey, I found this works better? AutoCAD works better. Rhino works better.
We will never, ever tell you what tools you have to use. Using a CAD is like riding a car. Everybody has his own preferences. Because of your workflow, each workflow is different. Some workflow requires Rhino, for sure, and but nothing else. Some workflow requires SolidWorks or Revit or whatever. It's definitely up to you. What we can do for you is making a software layer that adapts to your needs. So that's the current strategy for Mindesk, adapting to as many CAD software as possible. That's it. And today we are available on Rhino only, but we are adding SolidWorks very soon, and we're gonna add more and more in the next quarters. So, yeah.
Your Autodesk collaboration, that of course I would think allows for many Autodesk products have the virtual reality interface with Mindesk. Is that?
We are part of the Autodesk developer networks, and we are experimenting to find out which one is the one with the most potentials.
Oh, okay, sure.
That's what we are currently doing.
Autodesk Inventor, probably.
Yeah, possibly. Yes, Dave.
I have a question for Diego.
Sure.
Okay, you showed the product.
Yes. Well, speaking about recently what you just mentioned with Autodesk, there's a few softwares that we use that we do like from Autodesk, one is Fusion 360, but especially Maya. Maya's a lot more organic software that you can use for animation, and but people also use this type of software as basically T-splines or freeform NURBS that you can push and pull to create these shapes that are a lot more difficult to create in Rhino, and especially Revit. Rhino is very, in my opinion, the best software out of all these because it combines so much, but it does have its limitations. So software like Maya, if you were to create a very organic exterior skin, would be kind of nice to be able to push and pull this skin actively, where everything stays the same, where you don't have to resurface everything or reloft stuff, and you have smooth surfaces that can later be translated into parametric design, either using Grasshopper, for example, or using Revit to bring it all together. And yeah, I think it's not going to be like you're going to be making crazy shapes of floor plans. It's maybe more like a showpiece, like a feature wall, exterior skin element, not necessarily the standardized stuff that's more rectilinear. Mm-hmm. Yeah, I mean, one thing we do a lot, we just mess around with is lamps. We do a lot of lighting. Lamps are pretty nice because there's not that much structural constraints. You basically kind of make something nice that you put light in that you think is going to look pretty cool. And that's something that, for example, HOK has their own design, like product design that they make in-house, and then they sell that. So you could potentially go in and you could say, I want to design this lamp, and this lamp is going to be in 46 places in this tower. And that could be really cool. Or maybe like an organic bench that you want to have in the lobby or multiple lobbies, and then you can kind of like do that. So I think it would be very useful in that sense. We have not used it. As you saw, I just presented a very straightforward vase. But I think that with the speed that you could do that and how fast, what I've noticed with development of at least Gabrielle's software, Mindesk, it's been developing really quickly, so I can only imagine so many people are going into this. So to me, it's kind of like another layer of presentation tools. So you have like plan, section, elevation, axon, digital model, physical model. And then you have like this last, it's like another drawer to your toolbox. It's not like just one more tool. It's going to have a whole bunch more like features that bounce off of it. And in this case, I'm trying to illustrate how this goes directly with 3D printing, because if you have qualms about VR being real, what I'm trying to show is that it is real, and you can print something physical and tangible directly from that. So if that feedback loop is so fast, you'll be more inclined to use it. It's kind of like that diagram that he showed with someone walking through the grass versus walking around. If you can get comfortable with it quick and it's actually useful, which is becoming what is happening, you'll be able to implement it and bring it into work, not avoid it. Like people avoided AutoCAD and all that stuff a while ago, and now it's like 100% what's happening. Similar to Revit when it first came out, people were like, I'm going to stick with CAD, because internationally CAD is king. AutoCAD is what I mean. Yeah. Great. Any other questions? Okay. Well, thank you for stopping by. I think Gabrielle is about to set up the 3D VR. You guys test it out for yourself. I would definitely say be patient, because it's not what you're used to modeling with, but it has the same features. It just takes a little different automation with your hands, that's all. Okay, thank you.